Hello, Tom.
Hello, Priya. How are you?
I'm good. How about you?
Oh, yeah, I'm wonderful. What did you think of that brilliant keynote just now?
Oh, I thought it was awesome. It's always a pleasure to hear Emil talk to us. With that said, do you think it might have been a little too deep, for first-time attendees here at Notes 2021?
Yeah, possibly. Do you think we can do something about that?
Yeah, why don't we just hit the reset button and go back in time and talk a little about how did we come to be here? But you don't have to go all the way back to the Big Bang. You can keep it
Okay.
and short.
All right, I can do that. Let's have a brief history of Neo4j then.
Okay.
All right, so it actually is the tale of a man and a monster. Well, okay, not really a monster. It's the tale of a man and some nice Swedish nuts, such as Emil himself. Okay, so in case you didn't recognize the two at first, yeah, it really is the hat that makes the man, right? As you can see, they keep coming, they keep coming. I wonder if we should tell Emil about this. There is
No,
definitely a theme here. No? Okay,
no.
okay, okay. Not then. Okay, so skipping over the dinosaurs, in 1735, Leonard Euler kicked off a new doesn't happen every day, called graph theory.
Mhm.
And he basically kicked that off by solving a known problem of the day, which was called the Seven Bridges of Königsberg.
Mhm.
Königsberg being a city currently in Russia called Kaliningrad.
Mhm.
And Königsberg has a rather strange, well, the river itself is not strange, of course, but it runs through the city in a rather strange pattern.
Mhm.
And there are, or there used to be, seven bridges crossing that river. And the problem of the day was, can we devise a walk which goes over all seven bridges, but only once? So
Mm.
you had to do a walk across all the bridges, but you could cross each bridge only once. And the big insight of Leonard Euler was that this was not a geographical or topographical problem,
Mhm.
and he was able to reduce it to the diagram on the right, which basically has the land masses of the city as nodes
Mhm.
and the bridges as the relationships between them. And that was all that mattered to solve the
Right.
problem.
Mhm.
And that was a big insight.
Mhm.
So, skipping forward a bit to 1969, when we went
Mhm.
to the moon. Well, not you and I, obviously, but when men went to the moon, around that time, a standards committee was basically putting down standards for everything in IT. COBOL was one of
Mhm.
those things they designed, still
Mhm.
around today. And what they also designed was how databases should be built. And what they came up with was the CODASIL standard, which described a network-oriented or graph
Mhm.
database,
Mhm.
1969. Commercial products on that, so real graph database implementations, were around less than a decade later. So
Mhm.
they've been around for a while.
Mhm.
Skip forward another bit. In the early 2000s, a bunch of Swedish nerds, we mentioned them, that was to become Neo4j, then laid down the rules for the property graph. So the thing that Neo4j implements in the database is called the property graph. And yeah, that is now taking us to Mars. And as you can see,
Mhm.
very sensibly, the Mars rover is in the shade. Um, I guess it's in the sun on Mars now. But yeah, the guy next to it is Jim Webber, who obviously also hasn't heard of the concept of wearing a hat in the sun. Uh, so yeah, that is a short the history of Neo4j, but I actually haven't talked about what it is. So can you take us through that? Yeah.
Oh, sure, Tom. So Neo4j, as we now know, is a graph database. And it's also one that implements what we've come to know of as the property graph model. Now, the property graph model is one of the ways you can implement a graph model in the graph database. And Neo4j was the inventor of the property graph model. I've already said that one too many times. So let's look at what that is. All right, so data can be organized and stored as nodes, relationships, and properties. Now, what is a node? A node is an entity. It could be anything to denote people, places, things. It could be abstract concepts. It could be events. It could be objects, or it could also be object states. Now, relationships are what add structure to the graph. So relationships are responsible for connecting your entities together. And they could represent anything from associations to occurrences to behavioral links to anything that you might use to represent connections between your entities. Properties are what add color to the graph. You see the word properties used in the property graph model. So it's an important element of the model. And what it lets you do is add color to the graph in terms of assigning attributes and characteristics to nodes and relationships. Additionally, nodes can also be grouped or they can be bunched together into what we call as a label. Relationships can also be grouped into what we call as a type. And in addition to the type, a relationship can also carry a direction. So it's interesting and important to note that Neo4j is a property graph, but it's also one that's directed. So what that means is when you write a relationship to the graph, it will always carry a direction. Now, you might not want to query the graph using direction, and that's simply because you can traverse the graph in either direction. But when you write a direction to the graph, it will always maintain a direction. Right, so what are properties? Now, as we've seen, properties add extra attributes and characteristics to nodes and relationships, and essentially they're stored as key value data pairs in the underlying graph model storage. Now, what you see here on screen is a very, very simple example of what a property graph model might look like. You have three entities here, the company entity, which is linked to the employee entity using a has-see relationship. And the very same company entity is also linked to the location entity using a located-in relationship. Additionally, the employee also has properties assigned to it. And you also have the has-see relationship that carries a start date property to indicate the appointment date of the CEO. So a very, very simple example of what a property graph model might look like. And of course, you can extend this model to have as many entities in terms of nodes, relationship types, and properties that you may wish to model. Right, now let's take a step back and look at databases in general. So when we look at databases in general, what comes to mind is the whole spectrum of relational databases. And I think that's simply because of the time we may have spent working on one. And you might agree that relational databases have been around for more than 4 decades in time. And when we think of relational databases, what also comes to mind and what is synonymous with them is asset compliance. Now, Neo4j is a NoSQL database, and you might know that NoSQL databases weren't designed to be asset compliant, and that's simply because of the work that goes into making one. But Neo4j, did invest that effort early on into the product to make sure that the database was asset compliant. Now, what does that mean for us? Well, it means that your transactions are atomic in nature. They will either succeed or fail as a whole. They are isolated from one another. So a read won't know what the write is doing, the write won't know what the read is doing. And no matter whether the transaction fails or succeeds in total, it will always leave the database in a consistent state. And I think that's one of the most important factors when we look at consistency as a whole, because NoSQL databases promise you eventual consistency. And the way they do that is they distribute your data over several nodes in a cluster, which at some point might be eventually consistent. But that might just mean that, in the process of getting there, your data might end up getting corrupt and you may end up losing data. So Neo4j promises you consistency when you write a transaction and when you perform a commit on that transaction, your data is safely written to your durable store, which can be retrieved later, at any point in time. So asset compliance is definitely one of the biggest differentiators of the Neo4j graph database. But I'm sure there are more that add to the secret sauce when it comes to fast traversals. And Tom, would you want to touch upon what that may be?
So, with the help of Mr. Ping here, I'll have a look at the other secret ingredients. Not so secret. But yeah, first of all, Neo4j is graph native. What does that mean? Both on disk as in memory. When we load the database in memory, we are talking about a connected structure of objects. Right? Yeah. So it is a graph on disk, it is a graph in memory. Yeah. And that is illustrated the best by the next thing, which is index-free adjacency. What does that mean? If we look at two connected entities, at read time, they don't have to be joined together. As they are connected at read time, they know by pointer where the other entity is. So we don't do index lookups, we walk pointers. A third benefit, quite often overlooked, is the graph locality thing, right? If you look at a typical transactional application, mostly you're going to touch only a small portion of the total data set, yeah? You are a customer and you look at the things you have bought. Now, in a large relational database, you then touch upon the big table problem. Your small subset of the data set is in huge tables, which you have to walk through. In a huge graph, you basically pinpoint your starting location and you just walk the local area around that. So you don't have that problem. So yeah, there really is no secret ingredient. You don't have to. What is needed is a bunch of good engineers solving hard problems.
Right.
Cool. So yeah, talking of engineering, yeah. So this is what that could look like. This is a horrible slide. Anyway, so we have nodes, we have relationships, and they all contain, yeah, basically pointers to other elements, even to their own properties. If a certain size is reached, the properties are basically chained together. So it's all pointer walking. We don't do index lookups, we walk pointers, and that makes us really, really fast.
Right.
How fast? Let me show you, because we haven't shown anything so far yet. We just talked about things. So I am going to show you on a database which has 125 million nodes and 800 million relationships. So that is not small, right? That is pretty big as databases go. And I'm going to do a query on that. And the database is a social curve. So think Facebook, right? Where you have a person that knows or likes or follows another person, and they like the posts of that person and stuff like that. But we're going to focus on person knowing other person. And what I'm going to do is I'm going to take one starting point and then walk 3 hops out, right? Knows a bunch of persons that know a bunch of persons that know a bunch of persons. And I'm going to check how many unique people do I find 3 hops out from my starting point. So let me show you that. So first show you that I'm not cheating. This is the database. So it's 125 million nodes, 800 million relationships, and yeah, there is an adult actor tag, which is pink. Interesting. Let me do a query. The query itself is not that important, but what I'm doing is what I just described. I pick one person, and I'm going to walk 3 hops out and check how many people I find. And that immediately returns and tells me that I touched 75,000 people, 93 milliseconds. That's, you can ignore that. I'm going to do the same query, but now I'm going to actually get an estimate of how much work that was, right? And what I mean by that is I walked paths from a starting point, and I walked relationships, hops between people. So, and that gives me in essence, that tells me how many joins would that have been if I would just join the person table to the person table to the person table, right? That's basically what that tells me. So I'm doing the same thing, and that tells me I walked 160,000 paths, and 3 times that, I got 480,000 hops done in no time at all.
Wow.
Okay, so that is already amazing. That would be the equivalent of doing 480,000 joins. Let's try that 4 hops out. Let's up the ante a bit and say, okay, if I go 4 hops out from that one person. Okay.
Oh, that takes a while. Oh.
Yeah, that does take a while. It took 4 seconds to be exact, but look at the amount of work I did in 4 seconds. I did the equivalent of 24 million joins in 4 seconds. On average, I get between 4 and 5 million hops per second on standard issue laptop or machine or whatever. Okay, so that is the speed we are talking about here. Okay, so yeah, that is how it works technically. The database, but it's not just a database, right, Priya?
Oh yes, Tom, it's not just a database. So we call ourselves, the #1 platform for connected data. And what that tells you already that it's not just a database, it's a whole platform, it's a whole ecosystem. But of course, at the heart of the ecosystem is the Neo4j database. But when you look at the slide, it looks so lonesome out there, right? You'll have to put data in it to be able to work with it. So for that, we have a whole data integration layer, and you can employ any of the traditional methods to bring data in. You could have traditional ETL, and of course, we also provide you with the de facto ETL tool to help you with that job. But that said, there are a whole range of third-party ETL providers that can talk to Neo4j. We also have integrations with streaming and messaging platforms such as Kafka, which can help you bring data into Neo4j in near real time. And we also have a way to do bulk imports into Neo4j, either using the tool that we provide you with, or you could also write a script to do that in any of your favorite scripting languages that we support. Right, so now once data is in Neo4j, of course, developers would want to interact with it. They would want to see, query it, all of that, fancy stuff. And we provide you with the Neo4j browser tool to be able to do that. We also have a command line interface for people who are comfortable with the command line interface. It's called Cypher shell, and it can help you do the same things. Well, that said, how can we leave out the whole administrators? Now, there's a database sitting there, and you might want to monitor what's going on in there. You might want to administer the database, define metrics around, things that you might want to monitor. So for all of that, we provide you with admin tools to be able to do all of it. Now, there's a database there, and you might want to build applications that talk to the database. And for that, we provide you with drivers and APIs to do it. We have drivers in about 5 supported languages, but that said, there are also a whole bunch of drivers built by our community that can help you, build applications. We also have APIs to help you build applications. And very recently, we productized our GraphQL library, which is a library that enables you to build applications very quickly. It's a JavaScript library, and that's something that you can easily get started with. Right, so this covers the whole gamut of graph transactions. But one of the most exciting things of working with a graph database is the ability to visualize what's in there. And you might want to see, data in terms of patterns, in terms of links, in terms of networks, whatever it is that you might want to visualize. And we have a de facto tool called Blue to be able to help you with that. But that said, there are also third-party visualization tools that are available to help you visualize what's in Neo4j. Right. So now, how can we leave out the whole community of data scientists out there? One of the other exciting things with Neo4j is the ability to run your AI and the tasks directly on top of the graph without having to leave the graph database at all. So you can now do all of this with the extensive graph data science library that we have with over 50 algorithms at your disposal. So, right, so this puts the whole graph analytics in perspective here, which you can see sit side by side by graph transactions. And the whole thing comes together as an ecosystem. And I'm sure there's a lot more that I haven't spoken about here, but you see it's not just a database. It's not just a database, Tom.
It isn't. It isn't, really.
Yeah, it isn't. It isn't. Yeah, but that said, is there a way to interact with Neo4j, Tom? Do we have a query language of our own?
Oh, absolutely. We do, and it's called Cypher.
Right.
Oh, let me talk a bit about that. Who is Cypher? Yeah, that is Cypher, obviously. I mean, everybody always falls for that joke. It's the bad guy in the Matrix. Everybody knows that. No. So what is Cypher? Cypher is an ASCII art query language that allows you to intuitively describe your traversals through a graph. So yeah, Cypher you want, ASCII art you learn. Yeah. Where is Cypher going, and why is that important to show this diagram? Is, yeah, we are people in IT. If we want to invest our limited time and effort into something new, we want to know it is going places. So yeah, and in that respect, it is interesting to see that the same standards committee that has been sitting on top of SQL saying that was the alpha and the omega of things for quite a while, has decided in 2019, officially decided that no, it is not the end of things. We need something else for this property graph. We need what is called GQL, graph query language. And Cypher is going to be the main ingredient there. So yeah, you're not going to waste your effort learning Cypher. It is going places. You will learn the equivalent of what is today SQL. So we have to help a myth out of the world here. I just said GQL stands for Graph Query Language, and it does. But there already is an acronym, and you mentioned it just a few moments ago, which is the same thing, Graph Query Language, GraphQL. Those are two different things. So Cypher GQL is a query language for a property graph database. GraphQL is an open source document by Facebook, which describes a standard for querying both microservices API and describing those APIs. So both querying them and describing them. And it has taken off, right? There is no point denying that GraphQL, even though, yeah, it isn't really about querying a graph, it's about querying an API, has taken off. And to make things more complex, we now have an integration, as you also said, where you can have the GraphQL API query the database with GQL. That's going to be interesting. Cool. So let's finally look at Cypher in action. Well, in action, but look at Cypher because yeah, we haven't so far. So these are two equivalent queries, side-by-side comparison. Instead of a select, we have a match. So I'm going to take away the precious select. And what does this query do? Well, it's going to look at persons that have acted in this. Now, I don't see a much more easy way to describe that. If you look at the equivalent in the select, that goes all the way down to here. That's the same thing. Yeah? Which persons are we talking about? Well, we want the persons, actors to have a name that contains an A. Okay, that seems to be the equivalent. And then the select has a group by having, basically grouping all the actors with their movies and counting in how many movies they play. Okay, you don't see the equivalent, or you seem not to see the equivalent on the other end, and that's because Cypher does implicit grouping, right? It does implicit aggregation. So the fact that I'm using an aggregation function here, collecting the titles of the movies, is basically forcing the group by. Quite a few query languages work that way, by the way. Cypher is not the only one to use implicit group. We do the same thing. Now we want to be the actors to have been in more than 3 movies. And then we basically return the information exactly the same way. I would argue that because of this pattern in the match, the left-hand side is a lot more readable and a lot more intuitive. It really is intuitive, even though you have to get used to the ASCII arty thingy.
Totally.
So yeah, I would argue that, but of course I've been using this for quite a while. But there is a learning curve to this, right? And can you talk a bit about that, Priya?
Oh, sure. I think it's similar to anything new that we might undertake for the first time. You know, when you start with something new, you're so overwhelmed with the amount of content that's out there. And you might think that, oh gosh, you know, this is so difficult. How am I going to get ahead? And, you know, I don't see a path ahead and all of that. But then gradually with time, you will get to a point, a phase where all you can do is live and see and breathe graphs. And then you're, oh my gosh, this is wonderful. You know, I just want to graph all day. And I'm so in love with graphs. So you're going to get to that point with time eventually. That said, there's a whole bunch of resources out there to help you with your journey. And Tom, would you want to take you know, the viewers through what those resources may be?
Sure. So the first thing, you need to get it, because now we can talk about up and down the tree about it, but if you're not going to get Neo4j, you're not going to be able to play with it. So the first 2 options here, the Neo4j sandbox and the Neo4j desktop, are basically straight in your face when you log on to our website. The Neo4j desktop is an installation on your own machine. And so you download it, you click and point, and then you get the Neo4j desktop, which is a sort of a visual user interface to manage Neo4j on your machine. It is free. And while we haven't talked a lot or at all, in fact, about the differences between the Enterprise Edition, which is licensed, and the Community Edition, the Neo4j desktop for your own personal use comes with the Enterprise Edition. So you have the full product. Now, installing on your own machine is not always, especially not if you're in a large corporation, that evident, right? So hence the Neo4j sandbox, where you can basically spin up a cloud instance and play around with Neo4j. Now that is free, but it is limited in time. So the sandbox at the moment, you can keep spinning them up, of course, but the one sandbox, of course, is limited in time to 10 days at the moment. And it comes, and this is a benefit, I think, you can have one with a preloaded data set. So if you want the movie database, you don't have to learn how do I load this thing immediately. You can just preload it and start playing around with it. There is a Panama Papers dataset, there is a Twitter Trolls dataset. There are quite a few datasets to play with. And then there is a third option. Well, there are many options, but a third obvious option is soon going to be around. It's not there yet today, which is the Aura free instance. So Aura is our database as a service product. And we will have a free version of that for anybody to try out. This will be not limited in time, but it will be limited in size. Obviously, it's free. You have to limit the resource cost somewhat. But that way you can get started as well. So yeah, once you then have the database, you need to get trained. We discussed the learning curve. There is a learning curve. And the resources for that are also plenty. We have the Graph Academy, where you can get free trainings in Cypher, modeling, graph data science. There's quite a few of them. And you can also get certified there, which is interesting.
Okay.
Obviously, the product comes with full documentation on the website. There are examples there as well. And yeah, everybody at Neo4j blogs. I think everybody does, almost everybody does. So there are tons of interesting blogs to follow, examples of use cases. There are tons of videos as well. Something to look out for in your own time zone is whether or not when we do a webinar on a particular topic. You might be interested in finance or fraud detection or the life sciences. We do frequent webinars that you can join and where you can learn about those things. There are also non-specific training sessions around the globe. So that then gets you trained, and then eventually you run into a problem, right? That's how things go with technology, right? You download it, you play around with it, and then you get into a problem. What do you do then? Well, there is a main option there is to join the Neo4j community. So that is a large community, tens of thousands of people already. And yeah, come talk to us. We generally don't bite, sometimes. What you can also do is say, okay, you've done your homework and you've seen the value of the thing and you want to take it a bit further in your organization. Yeah, you should come and talk to our sales representatives who can help you with licensing and support. After all, their and our children also have to be fed. So yeah, that is more or less it. Yeah. So yeah, what do you think, Priya, that the main lesson or the main point of this whole talk was?
Oh, I don't know, Tom. Why don't you reveal it for us?
Sure, I can do that. Actually, it was this.
Oh.
So it is everything is connected throughout. The whole talk was a build-up of connections. And say for example, that Jim Webber is linked to Stephen Hawking. Wow. That's not that obvious, but the graph obviously shows it is. Right? Or that the Hunchback of Notre Dame is linked to Kung Fu Panda. It is all true, it is all possible. And the moment you start seeing those connections in your problem area, in your organization, that is when the value of the graph becomes clear. So yeah, absolutely. I think that was the message.
Yeah, absolutely, Tom. I think it was wonderful, seeing it all come together, and it was an absolute finale to our session. That said, Tom, it was wonderful talking to you, and to all our viewers if you've stayed with us this far. We wish you a good rest of the Nose 2021 ahead. Thank you, and bye-bye.
Goodbye.